now let's start putting that algorithm into action in code. So first we'll import all our necessary packages here. Once these packages are imported, now let's also define some of the important variables which are required. Now, the first one is NB, which is the number of bandits. Now here, don't confuse it with the number of arms. Now here, as I said, now if you look at this picture here, now each of these is a bandit, and each bandit has got 10 arms, let's say, but this picture is a little different, but let's assume that each of these bandits has got 10 arms, and there are so many 2000 of these bandits here. Now why do you need take 2000? It's just to average between behaviors of different bandits together. That's the only purpose. So that's the number of bandits which you are taking as 2000. And the next is the number of steps, which is 10,000 steps. So for each bandit, we're going to pull them for 10,000 different 10,000 different pulls we are going to make of the lever. Now the next one is the number of arms, which is 10, which is the variable k, 1 to k, in the k armed bandit. That is NA, which is number of. Now the last one is number of solutions we are going to apply. So first we are applying the simple averaging solution. Later on we will apply another solutions also. So we are just defining two different types of solutions. Now the variable for that, we are defining that right now. Now let's also define the matrices which we are going to store all these values. So first one is the matrix where we store all the rewards which we collect for each of them. So the shape of them is the number of solutions which we have, which is 2, the number of bandits which we have, and the number of steps for each bandit. So what we will do is ultimately when we aggregate that, we will aggregate it across all the bandits. So the final number of solutions we will have is, or the number of the shape would be 2 into 10,000 because we will be averaging across all the bandits. So we are initializing it to 0, the rewards. Another container which we are also going to track is the optimal selection. Now what is this optimal selections? We are also kind of tracking to see that whether the arm which we have pulled is the most optimal or not. What is the most optimal arm? Whether that arm has actually got the maximum value out of it. So whether we have pulled the arm with the maximum value. So we are just going to track that also track that over time. So that's the second container, which is the optimal selections container. So if you can look at it, the shapes of it is 2000 and 10,000, because 2000 is the number of bandits, 10,000 is the number of steps. Code on action mental node. Now having seen some of the important containers, rewards and optimal selection, let's get into one of the main ones, which is the container or the metrics for storing or the QTA values, or the most optimal values for the actions. So we are initializing this as with 0 values. So you can see you're just filling up with 0 values, and so the initial array is all zeros. Now what happens is, as you've seen in the equation, that this gets updated as and when the new values, or when the arms gets pulled, and based on the rewards it generates, this gets updated, and this is the actual value, the running value of an arm, and this is ultimately what determines which action are we going to take, or which arm are we going to put. This is what is determined by the value here. Is determined, the selection of the arm is determined by the value here. So in a side greedy method, we said that we pick most of the time the arm with the maximum value, and if the probability is less than that psi value, we'll randomly pick, but otherwise we exploit whichever arm has the maximum value. Now initially all these things are 0, but later on we will see that this gets filled up, or this gets incremented by new values as based on the rewards which gets, and then based on that you pick the maximum out of it. Now the next one which we want to see is what we call as the calibration values. Now calibration values is nothing but the reward distribution which we're going to track. Now each arms will be pulled, each arms will generate a certain kind of rewards, and this rewards is based on a kind of a Gaussian process. What happens is, so when you talk about reward, so there are two types of rewards. One is a stationary reward and other is a non-stationary reward. Now stationary rewards will be kind of fixed. Okay, we know for sure that this particular arm will have this kind of reward. So that's a kind of fixed. But a non-stationary rewards keeps on changing. The kind of reward which is generated by each of those arms will keep on changing. So here we'll adopt a non-stationary rewards. So to have a non-stationary rewards, we need to update the existing rewards every time. Every time an arm is pulled, we increment it with a Gaussian process. That is, we randomly generate some reward values, and then we add it to the existing reward value, and that's what these calibration values means. Arm calibration values means the non-stationary reward part of it. So this is where this is to store the non-stationary reward part of it. And the next kind of container which we have is the arm selected count. So we earlier learned that the step size is based on the reciprocal of the number of times each of those arm is pulled. So we need to track the count of number of times each of those arm is pulled, and this is the tracker for that. So initialized to all initially we initialize it to zeros, but as and when these arms get pulled, these matrices gets updated.